November 2025, Peak Energy signs a 4.75 gigawatt-hour sodium-ion battery deal in the US, the largest ever. December, UK-based Inlight Energy completes factory testing for its iron-sodium battery system. Same month, India's Naxian Energy launches sodium-ion storage for homes and businesses. In Germany, Fenagy powers up Europe's largest sodium-ion storage system near Bremen Airport. And in China, the world's first large-scale lithium sodium hybrid storage station goes online. It can adjust power output in 10 milliseconds, it can restart a dead grid in 20 seconds, and it doesn't use lithium, it uses sodium, the same element in table salt. So, what's going on? Why is the world suddenly betting on sodium? Lithium-ion batteries power almost everything. Your phone, your laptop, your electric car, but lithium isn't everywhere. Over 70% of global lithium production comes from just 3 countries, and lithium batteries also need cobalt, a metal that's even more scarce and controversial. When demand spikes, so do prices. In 2022, lithium prices jumped over 400% in a single year. The world needs more batteries. For EVs, for grid storage, for everything. But relying on a single technology with constrained supply chains is a risky bet. We need an alternative, one that's cheaper, safer, and doesn't depend on a handful of countries. Enter sodium. Sodium sits right next to lithium on the periodic table. They behave similarly, which means sodium can do what lithium does inside a battery. But here is the difference. Sodium is everywhere, in the ocean, in the ground, in the salt on your table. Over 1,200 times more abundant than lithium. And unlike lithium, sodium isn't concentrated in a few countries. It's globally distributed, reducing supply chain risks. That means lower material costs. Some manufacturers are targeting $40 per kilowatt hour, significantly cheaper than lithium. Sodium-ion batteries are also safer, more stable at high temperatures, less prone to thermal runaway, and they perform better in extreme cold, a known weakness of lithium batteries. The trade-off? Energy density. Sodium-ion batteries store less energy per kilogram. They're heavier for the same capacity. For long-range EVs, that's a problem. But for grid storage, two-wheelers, backup power, and industrial applications, it's a perfect fit. And the market is moving fast. In the US, Peak Energy just signed a 4.75 gigawatt-hour deal with Jupiter Power, the largest sodium-ion storage contract ever announced. First delivery of 720 megawatt-hour starts in 2027. The deal could be worth over $500 million. Their batteries use passive cooling, cutting auxiliary power consumption by 97%. Lower maintenance, longer lifespan, better economics. In Europe, progress is accelerating. Germany's Fenagy system, nearly 1 megawatt-hour, runs independently from the grid and supports EV charging on site. In the UK, Inlight Energy has completed factory testing with 83% round-trip efficiency. Mass production is planned for 2027. In India, Naxian Energy is targeting homes and businesses with modular sodium-ion systems manufactured locally to reduce costs and supply chain risks. The race is going global. India, China, Australia, Europe, America. In the first half of 2025 alone, global sodium-ion shipments hit 3.7 gigawatt-hour, up 259% from last year. Storage systems account for nearly 58% of shipments, followed by light mobility and electric vehicles. But let's be real. This technology is still young. Energy density remains lower than lithium. Sodium-ion isn't replacing your Tesla anytime soon. Most projects are still in demonstration or early commercial stages. Scaling up manufacturing takes time. Market forecasts vary wildly, from $2.4 billion to $19 billion by 2035. That uncertainty reflects the challenges ahead: technology maturation, cost reduction, and market adoption. But in the right applications, grid storage, two-wheelers, backup power, the economics already make sense. And that's where the growth is happening. So where does that leave us? Sodium-ion isn't here to kill lithium. It's here to complement it. Lithium for high-performance EVs and premium devices. Sodium for storage, safety, critical applications, and cost-sensitive markets. With costs dropping toward $40 per kilowatt-hour, shipments growing over 250% year-on-year, and projects scaling up across the globe. The momentum is real. Sodium-ion batteries aren't the future of all batteries, but they're becoming an essential part of the future